Hello, I am the Internet Pedant, and today we're going to play something a little different. And I don't know entirely how different because I haven't played it yet. This is a blind run of this, but this is TIS 100. It's just come up on Steam, and it's a programming puzzle game. Yeah, and all that it comes with is kind of a manual, but it's a manual for the computer, not a manual for the game. So I'm looking at this screen, for example, and I have no idea what's going on. Let's just click some things if we can click things. I don't know if it's the kind of game you can do that. TIS self, no. Oh wait, yeah, no, that did something. So specification editor. Okay, and the TIS 100 segment map, right? Create new programs, cycle counts, node counts, instruction counts. Let's click on create new program. Let's try that. Okay, we have to read a value from in X, which looks like it's here. Okay, that's fine. Read and write the value to out X. So we just need to get that to there. Okay. And here we need to read a value from in A and write the value to out A. Okay, that seems fine. I've read the manual and I kind of know the commands for this. So but we can hit, let's see, F1. And this is a little reference. Basically, this is a programming game. I think I already said that there. I said that anyway. But assembly programming, which I know about, but I've never done. This is sort of bare bones programming or an emulated version of it. So let's give this a go. Basically, these commands. This side, I think what's happening is this side is an example and this side is kind of the puzzle. These are all different processor nodes which can write a little program to. And so here it's showing these have all got the same command, move up, down. So what that means is you're going to get a bit of data in from up and you're going to send it down. So in X is coming from up and that's going to send it down, which is going to send it down, which is going to send it down to out X, and that side's going to be fine. Makes sense. That's what we need to do. Read the value from in X, write the value to out X. Here, we have no programming yet, but we need to do it the same way. But, oh no, a communication failure. We can't get through there. Although there is a debug button. Let me click that. Oh, okay. There's a plot to this game. Can't find a pen right now, so I'm just going to take notes here. It looks like short-term storage. Got this one at the swap meet today. Fella wanted $450 for it, but I talked him down to $200. Good deal. No idea who makes this thing. Never heard of the TIS series, and the architecture doesn't look like anything I've seen before. Ask the guy at the 151.n. Oh, that's a bit of corruption, I think, but no joy. Randy has a mystery on his hand. Okay, so the manual says that this computer was owned by your uncle who recently died, and this computer was on his desk, and you've been tasked to just mess about with it and see what you can get off it. So I'm guessing that was your Uncle Randy, and this was the computer we picked up. So this seems fairly obvious. We go move up left. Okay. Here we want to go move right. Oh wait, hold on. Already am I doing it wrong? Because should I be using the full word, or is it? No, I think that's right. So I think it's just the command that starts that way. So move right, down, move up, down. Is there? Can I use? Oh yeah, I can do control and hit the arrow keys to go to different boxes. That's I like that worked exactly as I thought it would. So that's convenient. And move up. I keep doing that. Move left, down. Okay, so if I run that, it should all go fine. Is that right? Oh, 83 cycles. Oh, yep. Okay, that's fine. I did that then. Yay. Oh, look, there's my scores. I don't know what the scores are, but okay. Right, return to segment list. Ah, right. So that was the first. Oh, I see. So you select different programs. And then these let you, so I can try, it remembers the program you did, so that's untitled program. Can I name it somehow? Maybe not. How do I don't know how to get back. Is it just escape? Return to the segment list. I don't know how to rename the program, but that's something for another time. While we're here, let's have a quick look at these other things. So F1 is the instruction set. Oh, I can't do that here, can I? anti-tamper certification. Tampering with the memory contents of this device is a violation of the law and must be promptly reported to the State Security Bureau. Now, by definition, isn't everything you do with a computer, any computer, tampering with the memory of it? I can't think of a single thing you can ever do with a computer that isn't in some way altering the memory. But anyway, memory checks. I kind of feel... Wait a minute, hold on. Whoa. Quantum Information Science Lab. Huh. I feel like there's more going on here that I don't quite know. But anyway, signal amplifier. I can't speak. Signal amplifier. Let's go. Read a value from A in, double the value, write it to A out. Or to out A. Okay, well, that seems pretty reasonable. Let's have a look at these commands here. So I just need to double the thing. Right, that's fine. So we can move it around. That's not a problem. That's easy. But how do we double something? Can I just add ACK? Because that would add, like, something to ACK, which is what we've just brought in. So I just want to add ACK to itself, right? Would that work? Let's give it a try. Okay, so we're going to move up. Oh wait, hold on. Let me have a look here. Yeah. We want to move up to ACK. So that's basically remembering what that is. Then add ACK, which adds ACK to itself, maybe, and hopefully, which will double it, and then move ACK right. Okay, and then that's simple. Move left. Oh, done it again. Move left down. Move up down, and we can copy that and paste that. Yep, that all works. So let's run that. Hopefully, if I've got this right, it will work. In fact, let's try this. If we click step, we'll do it one bit at a time. So we've moved. We're going to move up to ACK. Where is it? Oh, 66 is coming in. It's been put into ACK. There it is for that module. That's great. Then we're adding it. We've made it 166. Yeah, 132. That's right. And it's going that way. There it is. That's fine. That's what we want. And it's going down there. Meanwhile, next number's coming in. Moving it to ACK. And then we're doubling ACK. Yep. So let's run that. I think that should be good. 10 to 20. So that's expected. That's what we're actually getting out. And it looks like a match. Okay. I think we're good. Yes, brilliant. There we go. Wonderful. Return segment list. That's, again, nice and easy. Huh. It looks like there might be a quicker way to do this. I wonder. Never mind. That's not something to worry about. Return. This reminds me of the same company did a game which was basically, it was about putting molecules together to do things like building molecular factories, and this reminds me a bit of that, especially with this idea of recording sort of how well you did it, how efficiently you did it, and comparing it to other players, which I'm fairly sure is what that's doing. So anyway, differential converter. Okay, what does that mean? Read values from in A and in B. Not a problem. Let's do that right now. Move up to ACK. Oops. Oh, what am I doing? I've accidentally hit caps lock. I don't think it matters, but okay. So either way, we're now reading that into those two elements. Write in A minus in B to out P. Write in B minus in A to out N. Okay, let's think about this. Let's have a look at these commands again. It's not going to be doing one of them. One of them's going to be fine, you know? Doing both is going to be the issue here. Right. So to do in A, like, so we've got, I'm pointing at the screen to reference what I'm discussing. So we've got A here, we've got B here. Let's forget this in and out bit. We've got A here, B here. We want to take that away from that away from that. So on this side, we're going to need to subtract right from ac. Okay. And from here, we're going to need to subtract left from ac. But, hold on a second here. Hold on. Whoa there. Because if we do that, think about this. If we just tell it to do that, if we just say, oh yeah, read in the other thing and delete it, that's fine. By the time one of them has executed, that's changed what ac is, so the other one's going to be taking away the wrong number. And that ain't good. That's not what we want. Now, there's a few ways we could deal with this. We could have this, before it does anything, move the original value off this way somewhere. So it goes, oh, well, okay, well, A is over here now. And this is the original A. This is the unmolested A. And then that takes B and does stuff with it. Or maybe even this side. Actually, yeah, this side, then... Yeah, okay, so this side, let's look at B first, actually. This could be easier. This takes away from A, but A is still unchanged. It's still there. Then it takes it down here. No, that's wrong. B goes down, and A is brought down, and A is also brought this way. Then, no, I haven't got this. There's also a time. Oh God, this is brilliant. This is just you watching me program, but it's not even like actual programming. It's just a game. We also have. Let's think about this. What we have here is a timing issue. We need to make both things happen, but when one of them happens, it will change the other. So, we are going to save on both sides. So what that means is that each will, in fact, let's step through to show you, each will save that value both in ac and in back, which is a backup. And you can't do anything with back itself, unfortunately, but it will just sort of sit there and be okay. So, then we can have, let's stop that. So once that's done, we can definitely subtract right from ac, okay, which means also, oh, just sub right. So this is going to take that away from ac, which is good, which is what we want, which also means we need this to move ac left. Okay, so that's going to take B and move it there, and that's going to take it away from A, which is what we want. Okay. Then we want this to swap. Is that the right command? I think it's just swp. Yep. So then it's going to take ac, which is what our final value, and save it in back, where it put back into ac. So that's the original A now will be in ac. So then we move ac right. And this doesn't actually need to use back at all. Then this will subtract left. And if I've got that right, at that point, they'll both have what they need. This can swap again. And then it's just a matter of moving stuff down. Move ac down. Move ac down, and then these would just be move up, down. Gosh, I need to think. I might try and add some kind of music to this. Oh, that's the point. I know what I haven't done and what I should do just before we test. I think this is going to be right. We'll test it in a minute, but first, debug. Interesting. It looks something. There's some kind of static memory in this thing, encoded something or other. Huh. What that means, in a modern computer, you've got random access memory. You'll notice here, everything's got its own little bit of memory that it has to access directly. A modern computer doesn't do that. It's just got this big stock of memory over there, and then it says, I need to read that bit of memory and bring it back. I need to read that there. Like, this puzzle would be so easy with random access memory, but we don't have that. But what that's saying is that actually the computer does have some kind of big static storage somewhere. Huh. Anyway, right, let's see how this goes. We're expecting this first number to come out of P to be minus 49, and the first number to come out of N to be 49. Seems reasonable. I'm just checking in case we had to swap them over. That would have been really annoying, but no, it looks okay. So let's just pause that there, and that looks pretty much bang on. So yeah, let's fast forward. What? Yep, I did it. Okay, that's good. That's good. And you can do it with a lot less cycles, apparently. I'm guessing there's some kind of optimization with all this swapping and saving. But that's still pretty good, pretty middle of the road. Okay. Let's just go back to Signal Amplifier, because did that have... Yeah, that had some of these communication failures. Let's debug this side. Continues to baffle. Chatted with Bernie at IBM. And he says it sounds like they'd come up with in the USSR, but then why is the manual in English? Couldn't tell you. Right, let's get back out of here. Return to the segment list. Yeah, there's... Could you view the manual in-game? Oh, no, it opens outside, but you do get an achievement. I don't know if you can see that on the video, but I just got a Steam achievement for that. Okay. Let's do one more. Let's do one more. Create new program. Read a value from in. Fine. Write 1 to out G. Oh, let's do debug first. Let's do this. Found a block of static memory and knew it, but it's in a proprietary format I never saw before. Comment your head and tails of it. Oh, brother. There's just too many different kinds of machines coming out now, and I like tinkering with them as much as the next guy. But when every Tom, Dick, and Mary implements their own memory address scheme, it's all blah, 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 blah. I say the bottom's going to drop out of the microcomputer market soon. Mark my words. This was 1979. He wasn't right about that. So, read a value from in. Okay, so move up ACK. Fine. Write 1 to out G if in is more than 0. Write 1 to out E if it equals 0. Write 1 to out L if n is less than 0. When a 1 is not written to an output, write a 0 instead. Okay. So if it's more than 0, we want a 1 out there, if not a 0. Yeah, okay, right. That should be okay. What we've got here is these jump labels. So you can you can set labels to do things and then jump to them depending on different values, which funnily enough are if ACK is 0, if ACK is not 0, if it's above or below. Great stuff. So these should actually be pretty easy. You just take the input, say, well, if it's blah blah blah, then output a 1, or if not, output a 0, and then jump to the next one and let it do its thing. So that's not bad. So we can, in fact, no, we don't need to save this number at all. That's completely unnecessary. So here's what we're going to do. We will need to save it on these, I suppose. I think we probably can't just move it right along. No. So move left to ACK. So we're saving that. This one's the more than 0. So label. Oh, let's make this. Yeah, there. Let's set the labels first, and then we'll work out scheme. Sorry, I'm just not talking. You know, the one thing in this video, I guess, is me talking about what's going on, and I'm not even giving you that. I'm very sorry about that. So we need to set a label for more than 0. Let's just say that. Let's call it that. Is that how that works, or do I put that at the end? Is it like that? Yeah, it's like that. So we're going to do the comparison up here. So don't worry about that for a minute. But if it's more than 0, then we write 1. So move 1. Sorry, damn, done it again. Move 1 down. Okay. If it's, I'll tell you, actually, before anything else, we can just move ACK right. And the reason we'll do that right now is because that way we can carry on figuring out what to do with this signal while the next column is also figuring out what to do. So otherwise we'd have to go through the whole processing and then send it along. And what's the point of that? So we've sent that over there. Next, we want to see if it's more than 0. So what was on for that? What's comparison for more than 0? JGZ. So JGZ. If ACK is more than 0, go there. So JGZ more than 0. So if it's more than 0, it's going to come here. It's going to, in fact, wait, we need another label. Let's make that start. Hold on. There we go. So if it's more than 0, it jumps down here. It moves a 1 down there, and then it's done, I guess. So we'll jump to is it JMP? JMP start. Otherwise, if it isn't, then we move 0 down and jump to start. Alright, so let's think this through. So it takes a number, shoves it off there for them to deal with. Then, if it's more than 0, it jumps down here, says outputs a 1, and then restarts, gets a new number. If it's not more than 0, then it puts a 0 down there and jumps back to start. Yep, that looks about right. Okay, so now we can do the same. We can just copy paste that to here. So, get rid of this line here because it's not going to need to send that along. So this one. So E is put in if it's equal to 0. Equal to 0. I'm just changing the label. That's not strictly necessary, but it's just going to help me to figure out what I'm doing. Oh, what have I done here? Done the wrong thing. ET0. So if this is equal to 0, then we don't want JGZ. We want JEZ. Ah, that makes sense. Will this be JLZ? Will I have called that? Yeah, okay, this is good. Alright. I think that might be it then. G is more than, this is equal, this is less than. I think that's right. Let's give it a go. Let's run. Okay, and let's pause and just have a look at these. They're looking like they're coming out as expected, don't they? They all look like they're in pairs. That's pretty good. Idle time is pretty low, 3%, higher here, but that's okay. That's because that's waiting a bit longer for stuff to be moved along. Because it's just going through the instructions quicker, because the other processors are having to move things along. This one doesn't have to do that, so it's a bit more idle. Okay, that apparently is a pretty box standard approach, but oh, actually, no, what am I talking about? This is good. Cycle count, I'm at the lowest, so I'm not wasting any cycles. Node count statistics is fine, and the instruction count is pretty low, so there is a more efficient way to do it, but I've done a pretty good job apparently. Okay, let's just check something. Can I just is it enough to just remove just the blank ones? Like, will that lower my instruction count? Probably not, but let's see. No, that's exactly the same. Okay, that's fine. I like that. I like the fact that I can kind of puzzle it over. I can see that there's a better solution. Other people have found it. I just don't know what it is. I kind of appreciate that. Huh. Oh well. Anyway, right. Wait a minute. Of course I know what it is. I don't need these jump starts at the bottom, because when something's done its thing, it automatically jumps to the top. So if I run that now, there we go. See, my instruction count's gone down, and that is apparently as good as it gets. Oh, that's awesome. Okay, well, I think I'm done recording this. I'm probably not done playing it. This hits the right sort of spot for me. I'm kind of weird that way. If this looks interesting to you, then it is. You should definitely take a look. This looks like it can be a lot of fun. I'm guessing the specification editor, from what little I've read, kind of lets you make your own puzzles, which is pretty good. I like the idea. Let's create a new create a new program. Oh god, I don't know what I'm doing. Oh, so you can. How do you make your description? You don't. Okay, I don't really know what's going on there. That's okay. That's fine. Did I just pop? I think I might have popped. Edit specification. Oh, that puts it in a different file. Oh, I see. These are files outside of the game. It's opening up a browser thing for them. So whatever. But yeah, so you can make your own puzzles and then like share them through the Steam Workshop, I guess. But anyway, as I was saying, if you like the look of this, if this seems like something that would scratch a particular itch for you, you should definitely give it a go. It's 10% off at the moment. It's only like £4 odd at the moment in Britain. So yeah, I'm actually really enjoying this. This is pretty cool. I'm going to give it a bit more of a go. But for now, I've been the internet pedant. You've been you, whoever you are, and I hope who you are is a good person and you're happy with who that is and enjoying your life. And if not, then it will get better. I don't know what I'm on about. Have a good one. Bye.